little review from yesterday that's going to lead us into stuff today. If you have a 1 over anything graph, yesterday we did lines, today we're going to do parabolas. The x-intercepts of that line are going to be non-permissible values, and therefore vertical asymptotes. And we're going to think about parabolas, because does it make sense that you could visualize a parabola having 2 x-intercepts? Do you have a parabola having 2 x-intercepts? Can you visualize a parabola having 1 x-intercept? And is it possible to have parabolas with no x-intercepts? So if we would just draw those out, like a parabola with 2 x-intercepts, I can think of like either your parabola is opening up, right, like this. Could you also have 2 x-intercepts if it's opening down? Absolutely. So both of these situations would have 2 x-intercepts. Then, 1 x-intercept. What would have to happen for there only to be 1 x-intercept for a parabola? Any ideas? The vertex has to be on the x. So if I had the vertex right here on the x-axis, it would have only 1 x-intercept. Could you also do that if it was opening down? Sure. Only 1 x-intercept. And is it possible to draw parabolas with 0 x-intercepts? It is. Either up or down. But if it was up, makes sense that it would have to be above. Then it would have no x-intercept. Or if it was going down, it'd have to be below. Now, each of these 6 situations makes a different reciprocal graph. And those 6 reciprocal graphs are on your next page. And they do with no vertical asymptotes, 2 possibilities, 1 vertical asymptote, 2 possibilities, and 2 vertical asymptotes, 2 possibilities. And I give each of these graphs a special name. So you guys can guess what you think the special names are going to be. The hint I'll give you is the one in the bottom left is, I think, the official graph of Winnipeg. Okay. So, first graph. Does it remind you of anything? What would you call this graph if you gave it a name? Boring. Boring? It's kind of boring. I call this one speed bump. You see it? And then can you guess what the official graph of Winnipeg is?
Is it potholes?
It is potholes. The pothole graph. The official graph of Winnipeg. These first 2 don't have any asymptotes. The second one has 1 asymptote. If you have a red pen, you can draw it in. And the last ones here have 2 vertical asymptotes. And every 1 over parabola graph always has a horizontal asymptote at y equals 0. Any guesses for the next one in the middle, on the top? I can give you a hint, but I'll let you guess first. Okay, you ready for the hint? On this one, I get a little sometimes crazy about my asymptote. What do you think I call this graph? The volcano graph. Awesome. There's our volcano graph. So I don't know what an inverted volcano would be. Any suggestions? I do have a name, but sometimes it's like someone comes up with a name that's way better than I've ever come up with. I like switch. That's what I call it. That's what I call it, but if you think of something better. Trench. Technically, if you would go deep enough, you would hit lava at the center of the earth, right? So it kind of.
Like two sides of the same coin.
Okay. The last two. This one. Sad face, or sometimes I add a clown in there. I don't know why. It looks like a sad. See the frown? See the eyes? I know it's like a sad praying manta. Or like, no, not like a manta ray. Not a praying manta, that's a bug, right? Yeah. I see the manta ray a little bit more. Sad manta ray. Ooh, maybe I should change it. But you see the sad face? You see the frown? Ooh. Can anyone guess the last one? Someone in the other class guessed the last. That's pretty close. I call this one Batman. Okay, so these are the 6 possibilities when graphing reciprocal graphs. Could get the volcano, the trench, the pothole, the speed bump, the sad face, or the Batman. And we're going to do example 1 now and see which one we get. And just like the other day, we're going to draw 2 graphs. First, in one color, we're going to graph the bottom, the negative x squared minus 1, and label a bunch of points. And then in green, we're going to graph the reciprocal of it. Is the blue graph in vertex form? Remember vertex form? A, x minus p squared plus q standard form. Is it in that form? Yes. What is the vertex? If that is in standard form, we should be able to P and Q make your vertex. My vertex is at 0, because there's nothing with the P, right? It's just x squared, right? But there's no other x's, right? If there was a plus 3x, then you'd have to complete the square to get it in standard form, but there's just the x squared. So it's going to be at 0 minus 1. Which way does this parabola open, up or down? Down. And the a value is 1, so you could go over 1, down 1. Label 1 comma negative 2, and negative 1, negative 2. And then over 1, down 3. So we'd have 2 comma negative 5, and negative 2, negative 5. Draw the parabola. Then when we go to our reciprocal, we'll start with asymptotes. We draw vertical asymptotes at non-permissible values, and those non-permissible values are x-intercepts. Does this one have any x-intercepts? No. But it does go down forever, so you will have an asymptote at y equals 0. In fact, every parabola at every line, except for a flat line, will have an asymptote at y equals 0. Now we can take the points that we have. What is going to happen to negative 2, negative 5? It's going to go to, I want to go to green. It's going to go to negative 2 comma 1 over negative 5. What's going to happen to negative 1, negative 2? It's going to be negative 1, 1 over 2. Maybe I'll label that over here. What's going to happen to 0, negative 1? It's going to become 0, 1 over negative 1, but 1 over negative 1 is still negative 1. And then at 1, negative 2, we have 1 comma 1 over negative 2, and at 2 comma negative 5, we'd have 2 comma 1 over negative 5, and we get the famous Winnipeg graph, the pothole. I'm gonna get you to circle 3, 6, and 11B.